Yeah, so first is the classical approach. So this omega is the set of, so here each element or each point of the set omega corresponds to the outcomes. Okay. Of a random experiment. And here this is equal to finite, and let a subset of omega and assume all outcomes are equally likely to occur, then we can think the probability of A is, this is what our experience says, this. Okay. And you see that these things happens like when you toss a unbiased coins or you roll a dice or all this type of gambling cases, this thing happens that all the outcomes are equally likely. Umesh Pawar, please mute yourself. Okay, so but in many cases, like in scientific cases, when we do scientific experiments, then this is very much unrealistic to assume that all the outcomes are equally likely to occur. So for that, we have this frequency based approach or empirical approach. So in this case, what we do, so the set of all outcomes and a subset of omega, that means we call A is an event. In this case, take intervals then relative frequency of the event is if n A is equal to a number of outcomes in A by n. So empirical law of changes says that this Fn becomes stable if n is large. Okay, so that means this is becoming close to a number. Okay, becomes stable if n is large. But this has also some problem with this approach. The problem is that we assume these things that it will be stable. That is okay. So I write this. So in case P of A is limit of n goes to infinity if n A. So you see that this assumption that the convergence property of this frequency, relative frequency of this table if n is large. This thing we have assumed, this may not be true. Second is that it may not be able to trial the same experiments under equivalent conditions many times, and it may even have that even more than one time to run the trial is impossible. Like extremely rare natural events like earthquake or tsunami, this happens. So this approach has also some fault. So now we go to the subjective approach. So subjective approach means in this approach we actually use the mathematics and we use the information we gather. In the previous approach, that is the frequency approach, we also were using the information, but here we use the information more. And like I gave you one example, means here probability means before in the previous approaches we are actually determining the probability. In this case, in this approach does not determine the probability. Instead, here we assume the probability, and the probability of an event. So I gave you one example, that is what is the probability of earthquake in Kharagpur if it didn't happen in last 10 years. You said it is either very small number or zero. So this we are assuming. Okay. We are not determining this, assuming. So an event is the degree of belief of a person attaches. I will give another example, then that will be clear to you, I hope. To that event. Based on his or her available information. So, like I gave one example. So, suppose we have to give the probability. Suppose you have to give the probability of that to Rohit Sharma, the cricketer you know. Will hit a century in the first innings of a test. Suppose this happens that suppose you play this and suppose you have to give 1,000 rupees. You will give 1,000 rupees. And if you win, then you will means if Rohit Sharma centuries, or you can even invest less. Means not you don't have to invest only 1,000. You can even invest like 500, 100, anything you can invest. Okay. So if Rohit Sharma wins, you will get you will get back this 1,000 rupees. Okay. So you will give something less equal to ₹1,000 rupees. You will give for this to play this game. You have to give suppose less equal to 1,000 rupees. And Rohit Sharma, if he is the century, then you will get ₹1,000. Or if he doesn't, you will get nothing. So suppose the game is in Eden. So how much you want to give? Means I know many of you know or play cricket. So can you tell me if the game is in Eden? So how much you want to invest? I hope that will be quite close to 1,000, like 800 or 900. Right. So if you suppose in India, if the test in India, then you will invest suppose rupees 850. Then that means you are attaching this probability that he hits century is 850 by 1,000, so which is 0.85. And if it is outside India, suppose in Australia, you might be invest suppose 250. So here the probability you attach is or you assume the probability is 250 by 1,000 equal to 0.25. So this is the probability actually you are attaching to an event by the information you have gathered or by your experience. So this is not that you are not determining the probability, you are attaching the probability. Is the difference clear? Please tell me if the difference is clear to you or not.
Can you explain again in short, if possible?
Shall I explain again?
Yes, sir.
So I'm saying that suppose, so in the previous all approaches, you were actually trying to determine the probability of a certain event. Here in this approach, this subjective approach, you are not determining the probability of an event. Instead, you are attaching a probability. You are assuming a probability based on your experience or your information, and after assuming the probability or after attaching the probability to an event, you are working with that. This is the main difference.
So this is after the assumption that I have 1,000 rupees to invest.
Yeah, you have something less or equal to 1,000 rupees to invest, and if Rohit Sharma wins, hits a century, then you will win. In this case, you will get back ₹1,000. Means you will get ₹1,000. If he doesn't, then you will lose and you will get nothing. So if in India, probably will invest suppose 850, and then you will get 1,000. So that means the probability you are attaching with that event that Rohit Sharma hits a century is 0.85 in India. Or in Australia, maybe you will invest 250. So in this case, you are attaching this probability to that event that Rohit Sharma hits a century in the first innings of the test is 0.25. This probability you are attaching, you are not determining. Is it okay?
Yes, sir.
Okay, so before we go to some
Sir, in this probability calculation, what is this value in the denominator? Is this the maximum value we can invest, or is it this the winning amount?
yeah, this is the maximum value you can invest. So you can invest 1,000 rupees and you are investing you can invest at most 1,000 rupees and you are investing 850.
Okay, sir.
Okay. So I give you some more examples of how to attach probability to an event. This was one example. This was a heuristic example. It is how to attach probability to an event. So example 1. So we did this example before that is there are 1 2 ace balls, identical balls in a identical balls, means these are just these labels are there, otherwise identical balls in a box. Okay, and suppose our balls are then colored red. So what is the probability will attach? Attach to the event that you will randomly pick a red ball. So you tell me, so suppose our balls are then colored red, then what is the probability that you will randomly pick a red, draw a red ball from that box? So I think the probability will be R by S, right? So this you can actually draw from this conclusion you can draw from the classical approach, because picking or drawing each ball is equally likely. But we are not determining in this subjective approach, we are not determining the probability of that event. We are attaching or assuming that probability. But this knowledge or this information comes from like our experience or like classical or like from the classical approach. But this probability we are just attaching. Okay. Now there is example 2.
Sir, hello.
Yes, sir.
Sir, the probability we are attaching is the probability we found by experience.
Yes, by the experience or by the information we have got, means from the previous experiments, by those we are getting some idea, from that we are attaching that probability to that event. Okay.
Yes, sir.
Now second is, this is, so in the first case this was a finite case, right? Number of outcomes is finite. In the second example, the number of outcomes will not be finite. We shall see such an example in which how can we attach a probability to an event. So an isotope, so you know about isotope if you have read in physics or chemistry, of a certain substance is decaying is unstable, you know that. So, and it emits neutron and decays to a stable form. Okay. So, but it is impossible to say with certainty when a particular isotope will decay. Can you say this? Can you say this when a particular isotope will decay? Can you say the time? Can you find the time? We cannot. We cannot find when with certainty when a particular isotope will decay. But if we are given a large number of atoms, large number, suppose n atoms, then we can predict something. What we can predict that, let's see. You know that the rate of decay is minus lambda of 50. That is rate of is proportional to the number of atoms present. Okay, so the rate of decay is proportional to the number of atoms present. So here Ft says the number of atoms at time t. So from this, we'll get that Ft equal to e power minus lambda t if 0. Suppose if 0, the initial stage, the number of atoms is n. So if t equal to n e power minus lambda t. Okay, so take t0 greater or equal to 0. Then the number of atoms at time t0 is n e power minus lambda t0. And 0 less equal to t0 less than t1 less equal to t1, then the number of atom at t1 is n e power minus lambda t1. Is it fine? So number of atoms decay in the time interval t0, t1 is n e power minus lambda t0 minus n e power minus lambda t1. Okay, so the fraction of atoms decay in t0, t1 is n e power minus lambda t0 minus n e power minus lambda t1 by n, which is e power minus lambda t0 minus lambda t1. Okay, so this is the fraction of atom decayed in t0, t1. So suppose our experiment is to find when an atom decays, the time. So what will be the possible outcomes? Can you tell me what will be the possible outcomes? So all time means starting from 0 every time. That means the set of possible outcomes is 0, infinity. Is it okay? And suppose you take this interval t0, t1. What is the probability of an atom decaying in the interval t0, t1? Can you tell me what is the probability of an atom decaying in the time interval t0, t1? The probability will be, yes, the fraction. Yes. E power minus lambda t0 minus e power minus lambda t1. Okay, so this thing, this time interval, so this t0, t1 is one event, right? As t0, t1 is subset of omega, and you attaches this probability e power minus lambda t0 minus e power minus lambda t1. So this way, when the set of outcomes is infinite, you are attaching a probability to an event. Okay, suppose both t0 equal to t1, then what is the probability? Yes.
0.
Very good. If you take 0, infinity, what should be the probability? So these things means we are attaching
1.
1. Right. So you understand that how we can attach a probability to a particular event.
Sir, can you please give us one more example?
One more example. Okay, let's try. I made these two examples. I think the first example was quite easy, right? Means that is the good way to understand that. Okay. Another example. Okay. This example I'm also giving from. So I will try to give the example. I'm trying to making it now, but you have to participate in it. Okay, you have to participate in it.
Sure, sir.
Okay, so suppose like cricket, I hope many of you also watch football. So even I hope you know what is the situation in some country leagues at the moment. So suppose so what is the probability at this moment? So the same thing happens. Okay, that the team Barcelona will win a league match. Suppose the same thing that you have to invest less equal to ₹1,000. If Barcelona wins, you will get ₹1,000. And otherwise you'll get 0. So now, before the match, suppose you have to invest, okay, and suppose the two possibilities at this moment, suppose Messi plays or not. Suppose Messi plays. So how much will you invest? Suppose you know Messi will play the
1,000.
match.
1,000, sir.
Okay, so 1,000. So that
Sir,
means
actually,
you,
I will actually
sorry.
take out the data of previous years when Messi has played during the league matches and Barcelona has won.
So now we have to take
Then
the
invest
data
accordingly.
of this particular season only, because the previous season was different, maybe previous seasons. So this particular season, this is 1. Okay. The probability that Barcelona wins if Messi plays is 1. Suppose if Messi doesn't play, then how much you will invest?
50 rupees, sir.
650.
50? Is
100.
it okay? Okay, let's be more generous to Barcelona, take 100. So 0.1. So this is the probability you are actually assuming. Okay. if Messi plays, you're assuming the probability that Barcelona wins is 1. And if Messi doesn't play, you're assuming the probability that Barcelona win is 0.1. Okay. So this is you have assumed and this is you have given. I am not. Okay, so now, so this is the way of doing things. Now we have to do all this systematically. But before doing everything systematically, I want to do some problems from the classical approach. An exercise. A box contains ten balls numbered 1 to 10. A ball is drawn at random. So this is some problem from the classical approach. Okay, I hope you know these things much better than me. So a ball is drawn at random. So compute the probability that the number on the ball was 3, 4, or 5.
Excuse me, sir.
Yes, sir.
Sir, actually, I had a doubt that if
Sorry,
the probability that Barcelona wins, if Messi plays is 1, then why don't we invest 1 rupees and we'll get 1,000 in return?
Oh, okay, I have to think about that. That's a very good question. Just
Is the wager about
I think that it should be that if we invest 1,000, we get 2,000. If we invest 100, we get 200. Then it would make sense.
yeah, that may happen. Yes, I haven't thought about that. It should be the other way. Right. Okay, so I shall think about this later and then I will come to you, okay, for this example. Means I have to figure out this way, this whole
Sir,
problem.
excuse me, sir.
Yes.
Yes, sir. for every event, like suppose for example tossing a coin, we find the probability of any outcome by number of experiments, like a large number of experiments, or
right?
so by that information we assign the probability of heads or tails to be 0.5. So
Right.
so every probability is a attached probability by that sense.
Yeah, by that sense means the difference that we will see that in the previous approaches we are actually determining the probability. Okay, by somehow by assuming that all the outcomes are equally likely to occur, or by running the same experiment many times. But here actually we are not determining the probability, we are attaching the probability. And how we attach the probability? By our previous knowledge or experience. And after attaching the probability, we do the rest of the work. Someone's this is on, so please. Okay, tell me what you are saying. Some other guys were saying something.
Yes, sir. So if we attach what I'm saying that
Yes, Chauhan, Param, Jignesh,
yes, sir. Yes, sir. Sir, we are attaching the probability of a coin toss if it is a heads to be 0.5
right.
by the experiment data only. So it is called attached probability, right?
It is not attached. Yeah, you have to attach. By experience, you have to attach. I don't think this is called attached probability, but yeah, you have to attach a probability. You have to assume the probability beforehand. Okay, means you have done some other experiment or you have some experience. From that, you are attaching probability instead of determining the probability. This approach doesn't determine the probability. This approach assume the probability, then works, then does something else.
Okay, I understood, sir. Yes.
Okay, now tell me the box contains 10 balls, number 1 to 10. A ball is drawn at random. Compute the probability that the number on the ball was 3, 4, or 5.
Sir, 0.3.
Yeah, 0.3. So 3 by 10. So it is 0.3. Another exercise is, suppose 2 dice are rolled once and 36 possible outcomes are equally likely. So how many possible outcomes are 36, right? Now find the probability that the sum of the numbers on the two faces is even. So this is almost the classical approach because all the outcomes are equally likely. So find the possibility that the sum of the numbers on the faces is even. So tell me that what is the probability that the sum of the numbers on the two faces is even. So start with 1. So suppose in one face this is 1. 1, 1, 1, 3, 1, 5, right? Again 2 4 2 2 2 6. So in the first phase and second phase, so first phase, suppose this is odd, then here it has to be also odd. So this is 3 cross 3 equal to 9. In the first phase, this is even, then this has to be again even. So 3 cross 3 equal to 9. So number of,
Sir, half.
so yes, so cardinality of the event is 18. So by classical approach, so mostly these cases classical approach is okay because all the outcomes are equally likely. Probability is half. Okay.
Sir, can't we directly say that if we roll these two dices and all the outcomes are equally likely, then the only possibility is that the sum will be either even or odd. So both events are equally likely, so probability would be directly half.
You can say from that also. Now, so these two problems on classical approach is done. Now we shall, so heuristically we have shown this what will be an event and how to attach a probability to an event. Now we shall do everything rigorously. This is the mathematical way of doing probability. Okay. So first we define the probability space. So we have said what is probability space, right? You know. So probability space is that this is the collection of, the probability space is the collection of all possible outcomes. So even if something is not outcome, you can include, but you cannot exclude any possible outcome. Okay? So this is the collection of all possible outcomes, which is denoted by omega. Hey, mute your mic, then do whatever you are doing. So that means if you take any point omega, any small omega in big omega, then omega corresponds to an outcome, to a possible outcome. Okay, now comes little more tricky thing. So now comes the thing called event. So event is nothing but, so this is take a collection of subsets of omega. So what is event? So we say an event, so we says this before, A occurs if the outcome of the trial is represented in A or represented by an element of A. So like the case that the event is like whether Barcelona wins or Barcelona does not. Or in the example 2, the event is, in this example, the event is the event is that the atom will decay in the time interval t0, t1. These are all event. So event is actually a particular thing on which we want to attach a probability. So what happens that you are taking these all possible outcomes and take any subset. You can take any collection of subsets of omega. Okay, but which subsets you will want to take? For only those subsets to which you want to attach a probability. That is an event. Okay, so A is the collection of events or a subset of omega where we wish to attach a probability, or we can attach a probability to A. It may happen that any subset of, it may happen that there exists a subset of omega to which we cannot attach a probability. It may happen. Okay. So that means this collection is not the collection of all this collection is not the collection of all subsets of omega. Some certain subsets to which we wish to or we can attach a probability. Now, this is something that if we know the probability of suppose A and B, or if we have attached we can talk about the event that the outcome is either in A or in B. That is, theoretically, this thing is A union B. So the event is, so the event that the outcome is in either A or B, that means the event is A union B. Right? So if we know, or if you wish to attach the probability to an event A and to an event B, we also want to talk about the event that the outcome is either in B or in A, either in A or in B. So that the event is A union B. So you know all these theoretic definitions, A union B, A intersection B. Do you know these things?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So also you can, yes sir, anything else? Okay, so you also want to talk about the event that both A and B occur. So how to denote this?
A intersection B, sir.
This is A intersection B. So this event is A intersection B. We also want to to talk about the probability that A does not occur. So what does it mean? This is A complement. So all of you know A complement?
Yes, sir.
Okay. So that means this collection A, collection of subsets of A, subsets of omega such that, first of all, this is non-empty collection, okay? There will be at least something such that A implies, A is an event implies A complement is an event, and A, B are events implies A union B, A intersection B are also event. Okay, so this is called algebra or field, which we shall define in the next class. So anything else do you want to say? Okay, then we stop for today.
Excuse me, sir. I had a question.
Yes, sir.
Thank you, sir.
Sir,